So this is to go over another example for chapter 13, independent t-tests. And so this is one of the slides from class. And you see that there's a problem with the educational psychologist wanting to compare a traditional classroom with having a computer classroom. And so each class had 16 students, and the independent variable, the manipulation was which class they were put in. The dependent variable was the average grade. So then you're presented with the data. So the computer classroom had an average grade of 86 out of 100. The traditional classroom had a score average of 82. You're given your sum of squares, which can turn around and be created for our new pooled variance. And again, each class had 30 or 16 students. So that ends up being 32 total participants. T for two independent t-tests is two different groups. So each group had a separate 16 students. The way the question is phrased is there a significant difference between the two groups? So that's showing a non-directional research hypothesis. And you were given, it's also a two-tailed test with alpha 0.05. When you go to set it up, remember step one is words and math. Then you have your degrees of freedom calculation. Our new one is now the total participants minus 2. You're going to look up your critical region. Again, you can look that up in the All Math website or that sheet of paper. When we do that, I went and cheated and gave you the critical values 2.042. And then you're going to need to calculate for step 3. We're going to need to get the top of our new T formula. We're going to need to get the pooled variance that goes into the bottom of the T formula. The bottom of the T formula is the estimated standard error. And then you have your T statistic. From there, you're going to make a decision with our 3 statements and calculate effect size. So our effect size to do both is Cohen's d and r squared. So let's go ahead and set up our first 2 steps. So for our step 1, you take the square root of that. And when we do that, we get the square root of 4.5 plus 4.5, which equals the square root of 9, which equals 3. So 3 is the bottom of our T. So now we have all of our information, and we're going to go ahead and put that into our T value. So when we put that in, we get that 1.17. Now, if you look at the distribution, we have 2 and a positive 2.042. Our 1.17 is right there. So this is in this space, which is our fail to reject the null space. So we have to fail to reject the null. Then we have to say it's not significant. Then we have to give context. So computers in the homeroom don't impact their grades. We then are going to want to go ahead and do step 5. So this is step 4. Step 5 is we're going to go ahead and calculate effect size, which we always do with the new statistics. So you're going to go ahead and calculate r squared in Cohen's d for this. So again, when you do Cohen's d, you're going to take the top of your T and then divide that by your pooled variance, the square root of it. So you get the, so we get that 2160 over 30, and that's going to be our pooled variance, which is going to go ahead and go into this part, which is our estimated standard error. When we get the pooled variance, we get 72. So we've got 72 over 16 over 72 over 16, and then take the square root of that. So you get 4.5 plus 4.5, which is the square root of 9, which is 3. So 3 is the bottom of our T. So we're going to have that 3.5 over the 3. We get 1.17. That 1.17 for our decision making is in that white region. It's in the fail to reject the null region. So we now move on to step 5 for effect size. So when we do the 86 minus the 82.5, we get 3.5. That's going to be at the top of our T. So when we put that in, we get that 1.1 in that. Now, if you look at the distribution, 2 and a positive 2.042, our 1.17 is right there. So this is in this space, which is our fail to reject the null space. So we have to fail to reject the null. Then we have to say it's not significant. Then we have to give context. So computers in the homeroom don't impact. They're in that. So for effect size, we either have Cohen's d or r squared. Cohen's d is your mean difference, the top of your t over standard deviation. The standard deviation for us is going to be the standard deviation for our pooled variance. So we're going to take the square root of our pooled variance. When we do that, our pooled variance was 72, so the square root of 72 is 8.48. So we take the top of our t divided by that 8.48 and we get 0.41. If you look at the Cohen's d chart, same chart we used for our z and for our dependent t-test, you'll see that's medium in the medium range. So we do have an effect, but we failed to reject the null, so that's a probable type 2 error. The next thing that we could do, alternative to Cohen's d, is r squared. So r squared is t squared over t squared plus degrees of freedom. So our t was 1.17. So we take 1.17 squared, then divide it by the t squared plus our degrees of freedom. And so then we get our 0.044, which is about 4% of the variance is explained, which is a small effect. Also, since there is an effect and we failed to reject the null, that's a probable type 2 error.